series stuff today. What there's going to be, by the time we're done, there our big goal, one of them, there's two big pieces to Unit 5, but the first one is just to determine whether a series converges or diverges. You might say we did that yesterday. We did sequences. They're different. So our big goal for a while is going to be to determine whether a series either converges or diverges. If it converges, could you maybe figure out what it converges to? The answer to that is usually no. And then once we're done with that, we move into what's called power series, where they become functions. That's where it becomes applicable. That's where you get your polynomial for sine, cosine, e to the x, and the brainchild behind the programming of the calculators, and Euler's big identity, which is e to the I pi equals, anyone know? E to the I pi equals, it equals -1. It's sometimes called the most beautiful math equation of all time. We're going to prove that e to the I pi equals -1, but it's done using series expansions for e, and then it involves sine and cosine. It's very strange how it all gets tied together, and then its final end product is the transcendental e to the imaginary I times the pi, which, where does that come from? And then a 1, and it's just very strange. So some people say it's the biggest, like, coolest discovery of all time, but you're going to derive it, which is really neat. But for now, we're going to focus on what I call the tests, and there's 10 of them. There's a couple that College Board doesn't touch, but we're still going to touch on them. Today's task, it says up there, is geometric series. So by the end of the hour, you're going to be able to tell me if a series is geometric. If it is geometric, you're going to tell me whether it converges or diverges. And if it converges, you're going to tell me to what it converges. And the geometric is the only test, except for the telescoping test, which is never on the AP exam, that you can determine to what it converges. So that's a red flag on an AP exam. If it says the sum as I goes from blah, 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 of blah, blah, blah equals, and there's numbers, it's geometric, because that's the only kind you're going to have a method to determine what it converges to. Does that make sense? We'll do one other method called telescoping series test, but AP doesn't do that. So, that's our goal today. It's fairly easy, so you get almost no homework. It says on here, Khan Academy. There's a Khan Academy 1 set. I challenged last hour. I said if you actually took out your Chromebook and tried it, you could finish it in 1.5 minutes, and Cole finished it in under 2 minutes. Like, he got the first 4 right, it took him 2 minutes. So it's not labor intensive, but you might forget to do it because it's on your Chromebook. So it might be you want to just take care of it right away, because you'd hate to, it closes at midnight. You'd hate to get 0 out of 5 on like the easiest, quickest assignment ever just because you forgot. So log that in your brain. If you have enough time, even if you have 6 minutes at the end of the hour, you will finish if you get all 4 right in a row. And he did, and it was under 2 minutes. We clocked it. All right. So I can't give you a whole lot of homework for a couple days. Big bummer, right? The reason is because the challenge isn't how to perform the test. Megan's going to totally get geometric series test and how to perform it. And then tomorrow when we do the nth term test and the harmonic, actually those are easy, I get that. What do you think the big challenge is going to be? Knowing when to use which one when they're all mixed together. For me to give you a worksheet with 20 geometric series would be a waste of your time, because 4 is plenty. Like I said, Cole did 4 in 2 minutes, he's good. But so I need to get enough tests under your belt so I can mix them together, because that's the challenge. So today, we're going to go into your notes to the page that looks like Calc 1. Here it is. So go to this page. We're going to do a little bit of poking around on our calculators before we get into the geometric series. So take your calculator out, because it will evaluate a series. It'll evaluate a finite series. We're going to be heading out to infinity. So if we want to head out to infinity on our calculators, I'll tell you, usually if we just enter 99 or 999, the calculator will bail and round it to what it would converge to anyway. But so yesterday we did the sequences. There's a huge difference between the two, and some of you are going to goof them up. So yesterday, to repeat, when you have a sequence, it's a list, correct? That sequence converges if the list, right, the rule of sequence has a limit. And you just keep writing it. Like if the limit was 2, you'd write comma 2, comma 2, comma 2, comma 2, and that would be what the sequence converges to, correct? I talked about, but if that becomes a series and we start adding, then we keep adding to, and what's going to happen? The series would what? Hello. The series would diverge. So you're going to have to be very careful. Up here, I've got two very similar rules of sequence. A to the n and b to the n. I want you to split your screen. We'll investigate them separately on our calculator. So this rule of sequence is 1 over n. If it was a sequence and not a series, I would have it written as 1 over n like this. I'd take the limit as n approaches infinity, it goes to 0, and I'd say that the sequence converges to 0. Agreed? Same over here. For my b sub n, if it were a sequence and I were just writing out a list, I would say that the limit as n approaches infinity is 0, so the sequence converges to 0. When we talk about this series, we're going to start talking about what we call S sub 1, which is called a partial sum. It's called the first partial sum. It just means plug a 1 in and add it up, and it's still 1. So I don't need a calculator there. My second partial sum will be the first plus 1 over 2. So I'm just adding as I go. I'm doing an aggregate sum. I keep adding on the next one. I don't need a calculator for that either. Now I'm going to get lazy and I'm going to show you where it's located on your calculator because I don't feel like adding fractions anymore. So if you hit math and you hit 0, keep in mind when you press your variable tool, this xt theta n, it's going to give you x if you're in function mode, which is fine. But if it bugs you, go hit the mode button and move it over to sequence mode, and it'll put n's in. And that won't really mess you up, I don't think. Let's put it in sequence mode for a little bit just so we're being consistent. Yesterday we talked about how n is the natural numbers. We're putting in counts. So if you hit math 0, and if you were to do the sum as n goes from 1 to 3 of 1 over n, it will do 1 plus 1/2 plus 1/3 for you. Hit enter, and what does it say? Math is 0. It'll pop up that eSum tool, and I got 1.83 repeated. I'm not very helpful on that kind of a calculator. The Inspire, you kind of got to do you, but there's that one. All right, we're going to go have Haley do the fourth partial sum and somebody over here, Billy, do the fifth. Then we're going to bail and we're going to get to infinity a little faster, but not nearly very far. But I'm going to have you jump up to 99, and then I'm going to have you jump up the sequence to 999. So we'll get decimals for those. We'll analyze them, and then we'll make a conjecture about what's going on. So if I could have 4 people, you know, it's just math zeroing it. We don't all need to do it. But what was the fourth one? 2.0, come on, pen, 83 repeated. How about the fifth partial sum? 2.283 repeated. Not convinced that this is converging. Right? When I head out to 99, what'd you get? Now, if this is 2.28 something something, I'm like, okay, there's convergence going on. But what happens when you put in the 99? Can someone run it through their calculator? Okay, 5.17 some stuff. At this point, I don't really care. Keep in mind it's doing 1 plus 1/2 plus 1/3 plus a blah, blah, blah plus a 1/99th at the end of it. The limit is going to 0, but the sum is not, correct? Also, although the sum is growing really, really, really slowly, it's not really settling on something I can grab. Wouldn't you agree? So, although it's going really slowly, 999, what do you get? Did someone run it through for me? I am not at all convinced that this is converging. I'm convinced that it's growing incredibly slowly, right? I know that the limit that I'm adding is approaching 0, but it's not approaching it slow enough for this to settle. Agreed? So I would make a conjecture right here that the sum as n goes from 1 to infinity of 1 over n diverges. It appears to diverge. You might even want to put appears. We'll prove it later. It's actually one of the most famous series. It's called a harmonic series. Ties in with music a little bit too. But we will prove definitively that the harmonic series diverges in another section. Fair enough? So we'll leave that right there. But keep in mind, I like to use the word settling for converges and not settling for diverges. Because if you think of it going to infinity, it is, but it's going so slowly that I'm just going to say it's not settling. I can't grab it. When I go over and do my b sub n rule of sequence, they're almost the same. The limits are both going to 0, but what happens on this one, let's go create it. This would just be 1, and I'll have you guys help me. S sub 2 would be 1 plus 1 over 2 squared. I can do that in my head. S sub 3 would be 1 plus 1 over 2 squared plus 1 over 3 squared. And I'm going to bail pretty soon here. 1/9 is 0.111, right? So this would be 1.361 repeated. Now I quit. So I'll pick 4 of you. Bazal, do S sub 4 for me. So math 0 it from 1 up to 4. And then who haven't I picked on? Jimmy, if you could S5 it. And then we're going to head on a little faster. We'll go to the 99th partial sum and the 999th. And we're going to see that this one is going to settle faster. The question is it settling fast enough to converge? The answer will be yes in another section. All right, so do you have this one for me, Jimmy? What is it? 464. On the 5th one, oh, that's right, Connor, you were the first one. So 1.464 for the 5th partial sum. 1.464. Connor, what was yours? Now, even just that very slow growth when I'm not even close to infinity, just as being a creeper on my calculator, I'm thinking this sucker's converging. I don't know what to yet. I'm going to head all the way out to S sub 99. Who had that one? It won't give it to you? Does it? Oh, didn't I? Do you have it, Sophie? It tends to spin its wheels for a while up here because it's adding a lot of stuff, but that's not much growth at all, right? Now I'm going to go all the way to 999, and if you could just do second entry and go add a 9 to the okay. Okay, they're super close, right? So I would, if I had a gun to my head, I would say that this one converges. I don't know what it converges to, though. Wouldn't you agree? I have no clue, and we actually never will know what it converges to for this type, but we will be able to conclude that this one all will converge. It appears to. Here's why I'm starting with this. You got to be really careful that when the limit of the sequence is 0, you don't tell me it converges. Here's one where the limit goes to 0 and it diverged. Here's one where the limit goes to 0 and it converges, correct? Here's what you definitively do know, though. If the limit's not 0, any non-zero number, and you're doing a series, it's going to have to diverge. Do you understand why? You're going to keep adding something all the time, right? Adding something that's not, like even if it was a half, in my limit, I'd be going a half plus a half plus a half plus a half. That's not going to settle. What's it going to go to? Infinity, right? So we're going to have a test that says, it's not today, but it's a super easy test. It's called the nth term test for divergence. And all it says, Jimmy, is take the limit, and if you don't get 0, the function diverges, or not the function, the series diverges. Done. So easy of a test. When do you use it? On those ones on the AP exam where they have like 4 of them listed and it says which ones converge. And it'll be like, you know, the old I and I and I and I and all those, right? The first thing you're going to do is run a limit test through it. And any one that doesn't have a limit of 0, what do you think it does? And you're listening really well. If it doesn't have a limit of 0, it does what? It diverges. If it was that easy, I would be done. If the limit is 0, guess what it needs? One of the other 8 tests. And we're going to talk about the first of those right now. It's geometric series test. So some little bit of a common sense behind it. Now, again, if I didn't have weeks to do this and had to squeeze it in 1 week, if I was teaching at some college where this was in 1 semester, which it usually is, right? I'd have to give you all the tests. I'd give you about 3 a day, and then we'd practice, and then you'd take a test, and you'd have them all memorized, and you'd do it. But I have the time to make sure you really get what you're doing, which is helpful. So I have the time to do a few little extra things. And before I talk about geometric series, I'm going to talk about this 1 by 1 square. What's its area? Yay! You guys are so smart. Yes. Now, In theory then, if I were to cut it in half and take that half of the square, and then take, hey, and then take the other half, which would be a fourth, right? In theory, if the world is right on its axis, then if I cut this fourth in half and added an eighth, right? And then cut that in half, so I had a 16th, and I could do this till I croaked over and died, that check mark would be a 1/32. If I kept doing that to infinity, what should they all add up to? 1, right? So I'm telling you that by all logic, that should equal 1, and it does. There's going to be some times, though, in here where by all logic, it doesn't equal. That's why I have that whole paradox thing in there. Some of the times you're going to be going, this ought to be going to infinity, and you're going to go do all the rules, and you're going to get 2. You're going to be going, what the heck? You know, some things are weird. We're going to be doing something like even with some volumes where you're going to be going, that ought to be an infinite amount of volume, and it's not. And it's not about quantity, it's about how fast things settle. So this is 1. So really this is what I'm telling you, that the sum, as n goes from 1 to infinity, what would the rule of sequence be for this from yesterday? If it was a sequence, 1/2, 1/4, 1/8, what's its rule of sequence? 1 over 2n. Exactly. 1 over 2 to the n, right? This is 2 to the 3rd, 2 to the 4th. So 1 over 2 and to the n. That's the rule of sequence. Agreed? Are we good? What do you think? Right? So that equals 1. This right here is called a geometric series. And it's when you're always multiplying by the same thing. So you have some starting amount and there's a constant multiple. It's called geometric. You deal with them in Algebra 2, actually. We're going to deal with them a little differently in here. So go to the next page. According to what you guys just told me, that when it was a half, it ought to converge to 1, just by the 1 by 1 square thing. Correct? Let's take a look and see what happens with this. I'm going to have some of you take out your calculator because I want somebody to do this function, but let's run it out to 4. Who hasn't done a calculator for me yet? Krugs. Math 0 that. Math 0 is the new math 9. N is the new X. We're kind of retraining our brains a little bit. But go ahead and do what I would call S sub 4, the fourth partial sum. And then let's have somebody, it says to do 5 of them and then 10, but let's just jump to 10 and then let's jump all the way to 99. So if I could take 3 of you and have you math 0 and give me those, that would be super. What is it? Can you give me that as a decimal? It'd be 2.81 for the fourth partial sum. When I head out to the 10th partial sum, what do I get? Can you do a second entry and just change your 4 to a 10 for me? Or if anyone can just... And then we'll talk about common sense, then we'll talk about rules. All right. I am now, if I had a gun to my head, going to say, yeah, this converges. What would I guess? 3, let's try it. Let's go to 99 because usually the calculator will. So what the calculator's doing is it's saying, screw this. There's so many 9s. I'm just going to round it. So it's actually not 3. It's approaching 3, but it's getting there fast enough to settle at 3. So I'm saying 3. There's nuances in what I just said, but it's 3. All right. That should make sense with what we just talked about because this is really 3 times the one that Keegan told me, the 1 over 2 to the n, which we just said was 1. Wouldn't you agree? So it should make sense that that's settling at 3. Now, if you think about this next one up here, common sense, look at what I'm constantly adding and look at what's happening to it. What do you think this one's going to do? This will diverge for sure. Go try it. Go do S sub 5, S sub 10, and S sub 99. Go watch. Not only will it diverge, it's going to go pretty haywire pretty quickly. There's a reason numerically that we'll talk about. S sub 5 would run this up to 5, so it's actually going to add these first 5 terms in what would have been the sequence. What does it give you, S sub 5? Crank it out real quick for me. 11, not too big. 11.2, blah, blah, blah. I don't care. Now go change your 5 to a 10 for me. All right, veto. Not Zappa. Well, he's not in here anyway. Anyway, next one. Put a 10 on. My guess is it got quite a bit bigger. 169 point, I don't really care. I'm just looking at magnitude, so whatever. And then 99, go throw that in there. Oh, now I'm in scientific notation, right? What was it? 8.1 times 10 to the, wow, right? Wow, did that ever diverge? What do you think's causing the convergence of the first one? I could have just told you the rule. You'd be super successful. But what do you think's causing the convergence of the first one? There it is. Okay, on the first one, that common ratio was a half, right? The second, which was causing everything to shrink as I went along the line. And on the second one, it was 3/2, which is causing it to grow. It's like exponential growth and decay, isn't it? So the rule for geometric says this. First of all, to be a geometric function, you must be able to be written. I'm going to say able to be written in that form. College Board usually already puts it in that form, so it's kind of weak. We're going to take a couple from the U of M book and show you what those look like, just so you have a fair representation of how they can get pretty tricky to figure out. But as long as you have some common ratio, which we called R, on ours, it was a half for the first one, and then it was 3/2 for the second. And you're constantly multiplying. Then it's geometric. What do the rules for geometric say? If that common ratio is greater than or equal to 1, you get to conclude divergence. If it's less than 1, you're going to conclude what? Convergent. And this is the only one, except for telescoping, which AP won't test you on, but I will, that you can tell to what it converges. There's a formula for it. What does it mean and where does it come from? So that's next, because I have time to show you this stuff. I could just say, guess what? You do a over 1 minus r, and you could plug and chug, but if you really get it, you won't need to memorize stuff. So I'm going to go down here. I'm going to rewrite this, by the way. I'm going to write this as start over 1 minus common ratio. I'm not going to put any subscripts. I actually don't like where I screenshot that from. I'd like it if it was just an A, because it's not always a sub 1. It depends on where we start our count. So here we go. Here, if it's geometric, it can be written as some number plus it times a ratio, times the ratio again, times the ratio again. I'm doing a light proof, times the ratio again, on out to infinity. Are you good with that? If I were to multiply everything up there by r, just because I'm doing a proof, so you get to do whatever you want when you're writing a proof as long as it's legal. It's totally legal to multiply both sides of an equation by the same thing. The right-hand side would look like this. All right. Do you need to know this proof? No, but I kind of think it's cool, so I'm going to show you, Dougley. All right. What I'm going to do is subtract these two things. So I'm going to draw a bar right here, subtract them. What's going to happen on the right-hand side when I subtract the levels? Look on the right, and what's going to happen when I subtract? All is disappearing, except what? A. Okay, so if I were to subtract top minus bottom and we combine like terms and all our like terms would be opposites, everything's going on out to infinity, lonely A left here on the right. On the left, remember, I'm trying to figure out what the sum is. S stands for the sum. It's not S sub 3, like the third partial sum. I want to know the grand total of this. What is the sum? What am I going to do with the S? Factor it out. I love the proofs, even though you don't need to know them. They become helpful when you get to higher levels of math, just that you've been exposed. So even if you don't get them. So remember, I'm trying to find the sum. Boom. There it is. That's how we find the sum of a convergent geometric series. We just have to be careful with it. So on the next page, I'll show you how they usually get presented. Is this a blank page or what? Okay. So this one right here, first thing you do is you need to write it so you can see the powers of n. So this is 3 times 1/2 to the n. That's how I would write it. Do a little rewrite. By the way, limit goes to 0. All that tells me is that it might converge. right? The next thing up there that I do is say, hey, that's geometric. And you'd say, hey, that's all you taught us. Yes. But eventually, right, when they're all mixed together, what would tell you, Sophie, that that thing is geometric? The 1/2 is a common ratio. The R to the N. Okay, if you can write it or if it's presented that way, it's geometric. And if it says to determine if it converges or diverges, you would say it converges. You would have to give a reason because that's a 50-50 guess. So you would draw on the hypothesis of, or the test for this one, which is all about the R. So you're going to say it's convergent because of what? It's actually the absolute value of R is less than 1. What does it converge to might be a second part of the question. So it converges since, maybe I should use good, I'll write them nice since there's only 3, since the absolute value of a half is less than 1. To what does it converge? My sum would be, now this is where you have to be careful. Watch the index because it's the first term generated by the rule of sequence. This one, I'd put a 1 in. This one, I'll put a 1 in to get my first term. This one, I'll put a 2 in to get, you have to put the index in to get, it actually stands for the first term. So A sub 1 is a little bit unclear because you think you're always putting a 1 in. You won't be. It's whatever the index is. So watch. By the way, I already know what this one goes to. We did it on the calculator. We got a 3, right? But here's how it would work out. We did it by discovery, which is weak. So when I put in a 1, I'd get 3/2. That's my A. Over 1 minus the common ratio. What's the common ratio? A half. Yeah. So boom. I'd get 3/2 over 1/2. Cancel, cancel. The answer is 3. It's easy. Isn't that easy, Abby? So then the next one, if that was on the AP test and it's part of a multiple choice and it says which one of these converge, I know I'm crossing this one out right away because I'll go, hey, it's geometric. And the what? It's geometric with R greater than or equal to 1. It's actually the absolute value of R. So you would say this diverges. Okay, you'll eventually tell me it's a geometric series, but that's all we have today, so I'm not going to write that. But once we have all 9, you're going to have to reference what kind is it, what test am I running, what's my conclusion. I'm concluding that this diverges because it's a geometric series with the absolute value of the ratio greater than or equal to 1, and I'm done. What do you think, Billy? It's not so bad, is it? It's totally not bad if we can dissect them all like this, and we can. Why can we? We've got nothing but time. So we're good to go. Keep in mind, if you were taking this in college, you would have had to have all of this stuff done before Christmas. So you couldn't take 6 weeks, or you couldn't have done, you know what I mean? This is a 1-week chapter that kids totally freak out on because they have so little time, not because it's so difficult. All right, it's a lot to memorize if you're short on time. This one right here, I would say converges. I'd actually eventually say it's geometric, but this converges because the absolute value of the common ratio is less than 1. To what does it converge? Don't be sloppy, right? The starting term, which they call A, over 1 minus the common ratio. So let's set that up. My starting term, what would it be when I put a 2 in up there? What's my lead term going to be? Go ahead, tell me. If I were to write out the list from yesterday, what would be the first number in the list? Plug it in. What is it? 3/4. Yep, it'd be negative a half squared times 3. So it will converge to 3/4 over, and also be careful, it's 1 minus the common ratio. And what's the common ratio? Negative a half. Yeah, the absolute value part is to determine the convergence or divergence, but in the formula for the actual aggregate sum, you need to do 1 minus the negative 1/2. We'll do that, and then we'll confirm it on our calculator, and then we're going to go to the U of M ones, just to make, because there's nothing really too tricky about this right here. This would be 3/4 over 3/2. Agreed? Multiply by a reciprocal to what does this geometric series converge? 1/2. Write it down. All right. By the way, just knowing the like little tricks of all of them, if you see this question on the AP exam, find the sum of the series. What kind of series is it? That's the only one you're going to be able to find the sum. Okay? The other ones you're just going to be able to say whether it converges or not, but you won't know to what. All right? So this is a half. Go to your calculator and run it from 2 to 99 and see what your calculator says. 99 is the new infinity. N is the new x, right? There's lots of math 0 is the new math 9. Everything's similar but very different. What did you change? Yes, very different. Because that first number is always the very biggest or very smallest of them all by a lot. Good point. Yeah, weird stuff. It's just really weird. All right, did it say a half? Now, Billy ran it through on his calculator. I don't know if by intent or by accident he did a 1, and it converged to something completely different. But think of why. When you put in a 1, what's a sub 1? What's going to be on top of your fraction for the sum? Like, it's going to change drastically because that's going to be a negative 3 halves. So he's got varying numbers by just changing the index. It's fairly cool. Now, having said that, I want to show you how they're going to appear. Flip the page. Let's talk about them when they're a little bit more fun. All right, so I made up 3 fake ones, and then I put one that was on my son's I didn't want you to see the answer. This was on his U of M final. Don't look. Oh, don't look. No. All right. Before I do the fun ones, though, this was number 5 on that practice test that I said you're going to have to choke on 6 of these. The first one that you got was this one. It was a function. These are actually going to be called power series when they're functions defined by a series. But it's just said to find f of 3. So you were really doing this, negative 3/4 to the n. Go do that. There were 5 fractions listed. It was number 5. I said you guys are just going to have to guess, right? Go get it exactly. Because it said to find the sum, I know it's geometric. It's in my face geometric. College, they don't really make me work on what's the common ratio. It's staring me in the face. So I didn't screenshot the whole question because they're actually shut down for the month of February. I can't get on to screenshot any questions. But this was your number 5. There's 1, 2, 3. These were the answers. A was negative 3. B was negative 3/7. C was 4/7. D was 13/16. And E was 4. Go see what you get, and if you would have had that one right if you had only known how to do them. We're doing that one in red, which is this one off of your last practice test. I said you're going to have to tank it because you don't know how to do it yet. No, I just wrote it. Before we do the more difficult ones, I'm showing you how it appeared on your AP practice test. To be honest, the multiple choice for series is quite easy. It's the FRQ that's a beast. This question's easy. All right, let's just go do it. What is the very first term? Because this is going to equal the first term over 1 minus a common ratio. What's the first term? 1, because this index gets plugged in, right? Then it's 1 minus, what's the common ratio? Negative 3/4. In the denominator is a 4/7. What was the answer? 7/4, sorry. What was the answer? 4/7. And take a look. It's there. It was letter C. You would have had to guess. But how easy of a question, right? That was one you had to skip. Now, I want to make it more interesting because I have time. So if you were doing this out of a true textbook, which we're not, you would have some like this where you have to play with it because you need it to be in the form of something times a common ratio to the nth that you're adding up. The trick of it is to create the common ratio. So you need to separate the n from the +1 and the 2n from them. You have to play with it a little bit. I'll play with this first one and then you'll try the second one. I'm going from 2 to infinity. That's important for that lead term. By the way, if it said to find the sum, I know it's geometric. It has to be. because all the other ones we're not going to be able to do. We'll just be able to tell if they converge. I've said that a lot, but it's actually very helpful. So instead of 3 to the n times 3 to the first, I'll write it as 3 to the n times 3. What I'm trying to do is create a common ratio. Guess what I'll do with this one? How am I going to create that common ratio? What's going to happen with this? What do you think, somebody? Yes, I'll end up dividing. So I'd have 2 to the first, right, times 2 to the negative 2n. So I could throw that one down in the basement like this. I'm trying to create a common ratio to the nth power. Then I'm golden. This is almost there. You just have to know that 2 to the 2n is really what to the nth? 4. Yeah, it's 2 to the 2 to the, you multiply the exponents and you're nodding. So this really right here is 2 to the second to the nth. They are equivalent. So this is 4 to the nth. Now I can suck out my common ratio and my lead term that'll help me get, see, calling that A out front, I like to call it the start. All right, so really I will be taking the sum of 5, 15, 30 will be hanging out front. What's my common ratio? 3/4, right, to the n. Hey, will I put one of these on your test? What do you think? You know me well enough, sure. It's not all about the AP test, so yes, I will. And it'll be on a no calculator part. So you're going to have to play, and you're going to have to figure out what the sum of this is. You'll know it's geometric because you'll have heard me say at least 100 times in the next 6 weeks that the only type that you can find to what they converge is geometric or telescoping, which the AP test will not test you on. All right, so I will, but I'll tell you, find the sum of this telescoping series, so at least I give you that clue. All right, to what does this converge? Well, let's go see. I need the starting term. Plug the index in. It's not 30 unless this started at 0. That's the most common mistake. Kids just say, oh, it starts at 30. No, it doesn't. This one starts at 30, right, times 9/16. Plug it in. That's my A over 1 minus R. What's 1 minus R? 1/4, right? Then I'll play numerically by multiplying by a reciprocal. And I'll do a little arithmetic. Hate that. You guys know I do. I'm just playing around. I got 274s, Billy, which bugs me because they're even. So let's go to 135 halves. If life is good, go to the original series and go to your calculator. Go to your calculator. Math 0 from 2 to 99. The original. And you better get the decimal version of this or I went way too fast. But I already did it, so I know that's right. You have a quizzical look on your face. Because it's A over 1 minus the common ratio, and my common ratio was 3/4. Good question. Had it been a negative 3/4, it'd be 1 minus a negative, and I'd add it. So if you were to run a math 0 on the original, which on your test, this would obviously be on a no calculator active page. Otherwise, why would I do it, right? With modern technology, it can tell me pretty much what that converges to. What did your calculator say? What is half of 135? 60 what? 7.5? Done. Go do the next one. If it says to find the sum, you're like, it's geometric. If it's geometric, there's a common ratio. You need to find it, and then you do A over 1 minus R. On my son's second semester U of M final, when he brought it home, the next one was on there. I was like, sweet, that's a good one. It might be. A is the start, the very lead number if it were a sequence. So you plug the index in. If I'm going to add these up from 2 to infinity, it will start at 2, and when I plug in a 2, I get 9/16, so it'd be 30 times 9/16. If this said 1, then A becomes 30 times 3/4. If it said 0, then A becomes 30. It's the lead term if you were to write it out. There, we got the aha. That's why you really have to I'm purposely not making them all at n equals 1 or n equals 0. I'm messing with it because it's the starting amount over 1 minus the common ratio. By the way, does this one converge or does it diverge? What do you think? The second one? It converges. What's the common ratio? 7/9, which is less than 1 in absolute value. So I know it converges. To what does it converge? The very first term I'd write down. This one I'd have to plug a 0 in, right? So let's go do it. I gave you pretty much time there. So I will rearrange this so I can see it in a geometric. This is good. The 2 is fine. And then I've got something to the nth, which I like. And then this is 5 times. I'd write that as 9 to the nth. Then I'm just going to deal right here. There is my series in its good form, right? What is A, Dudley, on this? What is the lead term? Because I have to do A. Nope, A is not 0. Oh, what is A? 2/5. There you go. 2/5 over. You are slow today. 2/5 over what? 2/5 over 1 minus the common ratio. What's the common ratio in this problem? 7/9, correct? So 2/9. What's my answer? To what does this converge? 9/5, right? Now, I think I'll skip this last one so that you guys can go in and do that Khan Academy really quickly, but you can see how this one's going to be 3 to the n times 3 to the first over 2 to the n. By the way, what's this one going to do right now? Diverges. You can start to see them. You know, it's not as hard as you would think. This one's tricky. I want to see if anyone can combat it. Go ahead and try the next page. I don't expect many of you to figure it out. I'm just going to tell you that. Go try it. You've got an issue right away in that it's a sum and not a product. Deal with it. How have you been taught how to deal? Yes. Yes, sir. We've been taught what to do when the integrand or the limitant, which I made that up, is in that shape. Yes. It's illegal. Yes. That's not why I put it on. That's not why I put it on there. So this is actually a sum of 2 convergent series to which I want to know what the grand total of the 2 is. I didn't write it, but I like it a lot. Anyway, I'm going to take this headset off. Your assignment is just the Khan Academy 4 that have been assigned